Hello friends, this is Sai Fanindra from SQL School, and I assure you complete practical training approach with real-time methodologies for our beautiful and colorful Azure Data Engineering Training Program. This course also includes a certification guidance for DP 200 and 201 examinations. Come on, let's get started. Let's understand about our actual and the curriculum. Before that, let's see what we are actually going to learn here in this course. So this particular course, the Azure Data Engineer training program, box number 7 in this particular diagram, the complete course as roster, carefully planned as per the DP 200 and 201 certification examinations. And this particular course involves 3 different plans. Plan A, core data engineer, that includes right from the Azure basics and fundamentals to data factory, Synapse for data warehousing activities, ADF for ETL activities, BLOB, table, queue and file storage activities, data lake components and analytics, big data analytics with table valued functions and U-SQL concepts and Hadoop configurations, mainly for big data operations. And we have Databricks for ETL and data analytics with Spark clusters, Python, Scala and SQL notebooks, Databricks file system and data frames. It involves examples on Cosmos, containers, document, JSON keys, and working with specific Cosmos migration activities. And also, this particular course involves a real-time project implementation. And for this implementation of the real-time project, the end-to-end real-time project requires SQL and TSQL basics, as well as the Power BI for reporting components. So Plan A includes Azure Data Engineer, a 6 weeks program. Plan B adds SQL and TSQL queries for 2 weeks, extensive course for 2 weeks. And we have additionally Power BI for big data analytics and integration activities, especially for Azure app registrations. Coming to the concepts, yes, from the basics of Azure fundamentals to Azure Active Directories to Azure key vaults and functions to service principals and SQL database, including on-premise migrations, Synapse with architecture, different types of tables, imports, and bulk load activities, create table as select concepts, data factory operations including ETL, incremental data loads, transformations and triggers, and Azure storage components, a lot of security activities, and implementation activities with Azure Storage Explorer tool. And we shall be understanding about data lake storage called Gen 1, including transformations, tuning options, role-based access credentials and security activities, POSIX concepts from Hadoop, Yarn and ADL metrics, the Azure Data Lake metrics and alerts. We shall be practically understanding about U-SQL jobs, managed and external tables with examples on U-SQL concepts, auto scaling and manual scaling options, Visual Studio extensions and add-ins for data lake, databases, tables, procedures, functions, etc., including TVF, the table valued functions. And we'll be taking examples on Azure Stream Analytics, different patterns and relations with IoT, Internet of Things, event hubs, jobs triggers, ETL operations, Azure SQL DB jobs, and Power BI analytic operations. And we have Databricks analytics in this course. That includes Spark clusters, Databricks file system, different kinds of notebooks with cells and commands for various levels of practice. And it includes, the complete course includes the operations pertaining to, right from the basics, but including the Cosmos, different kinds of networking activities for integration of all the components for Databricks, Data Factory, SQL Server, and Synapse databases. And we shall be involving in different kinds of activities for global distributions and security management, Cosmos, end-to-end implementation activities, and the complete lab plan on my screen here. Either you go for live online or on-demand videos. It is the same course curriculum. The Azure Data Engineer components. We have few specific storage components that we need to practice, ETL and analytic components to practice, and implement security activities. Other components like Azure Functions, Monitor, Data Share, Internet of Things, and Event Hubs, which are more into data science, but they are specifically mentioned in the DP 200-201 certification curriculum. So good to know about them with examples, how they work. And we have tools like Data Studio, Storage Explorer, Visual Studio, and data import tools. So these tools you would be installing in your computer. Any Windows operating system is enough to start with our course. And data access with SQL, U-SQL, and NoSQL. Make sure you have some basic knowledge on SQL before we start off with our lengthy course curriculum, to make our classes more useful with good amount of examples throughout the course, 100% practical and 1000% real time. The duration of this course, for right from the basics and ending with the end-to-end implementations, it would be about 6 weeks and a real-time project. We got regular as well as weekend schedules, so you can plan for any one of them. And you got the detailed course curriculum, starting with the fundamentals, the basics, with the server and migration activities. Then we shall be taking, after all these basics, we shall be understanding about data factory activities and Synapse, storage, data lake, and stream analytic operations. We shall be taking Databricks, Cosmos, as well as Azure Functions activities, ending with a real-time project after 30 technical and highly practical classes on core data engineer. And yes, either you go for live online, in-house classroom, or 24/7 on-demand videos, either of them. The same curriculum, same schedule, and my support. Even if you opt for the video training, my complete support for your technical doubts and clarifications. I'll be at your reach. You can contact our team 24/7 to know the details or the registration or a live demo kind of thing or whatever. You can call our team. And now with this introduction on the course, let's get into what is Azure and what we do as a Azure data engineer. Come on, let's get started now. So here we go. Cloud, a platform to ensure 24/7 access to your data, accessible using browsers and also using tools. We'll be working on multiple tools like Azure Data Studio tool, Storage Explorer tool, Cosmos data migration tool to work with various types of resources. And Azure offers free trial that should be absolutely enough for our entire course practice. Back to my notes. So it is through browser, as I was showing you just now, through the portal, we would be able to work on our components, storage components, like for example a server, say SQL School Prod server, or a database like a Synapse, a warehouse, or it can be through the tools from your computers. We can work with the cloud, a remote storage access platform. Why to go for a cloud? Yes, for example, assume you have an Excel file. Assume you got an Excel file in your computer, in your PC. Now, for some reasons, you upload it to Google Drive, right? Say for example, in Google or some other online drive. Then what's the advantage? Yes, remote access. As long as we carefully, cautiously ensure proper access with some OTPs or second level, 2-tier or 3-tier security levels in Google, we can make sure the data is securely accessible across the globe. Flexible data access. That is the main secret of cloud. Yes, 24/7 availability ensured. Good amount of security levels. We pay more to the cloud providers and we enjoy more services. Yes, for every cloud service and for every cloud offering from different companies, it's all about secured data storage. No physical infrastructure is involved, hence low maintenance overhead. Most of the activities are almost automated. What do you mean by maintenance? Yes, for example, let's take some database here. We see, like for example, a Synapse database, which is the main part of our course, ADF, Synapse, and Databricks. Three major activities including the storage and Cosmos. Here we have the backup facility, automated backups, automated maintenance schedules, automated workload management. I mean, for example, more amount of data is being sent to the Synapse database for data insertions or modifications. Accordingly, more resources can be allocated. And during off-peak hours, we call non-business hours, the resources can be released automatically. It's highly flexible environment, any type of cloud you take. No physical network is involved. We shall be creating something called as virtual networks. I repeat, a term that we need to understand and remember, something called as virtual network, as you see here. Yes, I created a virtual network to just show you a small example on it. Here it is, just to get some overview. No physical involvement of any cabling, etc. That may have some tearing or some other maintenance activities like wear and tear activities may be involved there in physical environment. No wear and tear here. I mean, no need of repairs. Everything virtualized, fast, super fast. No physical storage is involved. We will be creating our own virtual databases on virtual disks. Easy security and threat management. Good amount of protection, different levels of protection that we are going to understand in our course for the security implementation. That includes like key vaults, passwords, service principals, etc. Automated service packs and application upgrades, and supports the open source environments. In our course, we will be taking Spark, NoSQL, and KQL, we call custom query language for monitoring. Now, there are different cloud providers in this world, and the most popular ones, mainly for data engineering activities, Azure Microsoft Cloud, the most powerful cloud. And we shall be understanding technically with examples and comparisons with Azure Cloud versus Google Cloud Platform GCP and AWS. We have one particular chapter exclusively for comparing the cloud providers in our course. And it's good to know like when to go for which. And undoubtedly, Azure has a lot of advantages for us. A cloud platform that can be capable enough to store any type of data with ease, simplified, cheaper, highly secure. Any type of data, any amount of data, any type of application, storage applications, ETL applications, analytic applications, or data sharing activities to social sites, anything with ease we can do using Azure. That's the main fundamental secret here. It's a really easy and cool way to enjoy the beauty of Azure. Really, Microsoft makes it very simplified and straightforward. So why to go for Azure now? Cheaper compared to other Azure, other cloud technologies. Azure is very much cheaper. How much it cost? Well, component to component, the pricing matters. Component to component. For example, we have Azure Cosmos. We can start with a 15 days trial. We love the services, then we'll upgrade it. It will be costing about $1 for every 100 gigs of storage. Same way, for example, we have Azure Synapse. We need to pay per hour. About per hour, it would be minimum of $1.5. But again, there are various options involved inside. Comparatively, when you compare with on-premise cost, when we carefully compare with an on-premise, I mean non-cloud infrastructure, capacity, storage, networking, maintenance, and other activities pertaining to even manpower cost and including other taxes involved, yes, the cloud costs are very much less. Otherwise, no company is going to migrate there, right? As simple as that. Yes, really, friends, it is really true that cloud components costs were very high once upon a time. Now, thanks to the technology, it's improving a lot with a lot of nice alternative mechanisms coming up now with reduced cost and more increased environments for implementation of technical activities and technical requirements. So component to component, we say resource here in Azure. From one resource to another resource, we call it as resources. For example, Databricks is a resource. Storage is a resource. Synapse is a resource. Data Factory is a resource. So resource to resource, the pricing varies. Comparatively, Azure is very much cheaper compared to others. Very much more secure, easy integration, and suits Windows and non-Windows platforms for the tools and accessibility from the end users. In cloud, in our course, from the basics, we need to understand about something called SAS, Pass, and Years. We'll be taking with examples. For now, a small basic one-liner definition. SAS, the first one, It is 100% cloud. No software installation. It's completely logical computing activities. Best example in our course, ADF, Azure Data Factory. Completely cloud. PaaS, platform as a service. 80% cloud, 20% non-cloud. Like for example, we have few specific storage activities, and for the storage operations, you may need to use a tool from your computer in addition to the browser-based cloud activities. 80% cloud, 20% non-cloud. Infrastructure as a service, IaaS. 50% cloud and 50% non-cloud. This involves the storage activities, networking activities, like virtual networks and disk system, memory, processor, CPU allocations that we will be understanding in clusters. We have something called hybrid and Hadoop clusters in Databricks concept coming up next. So there we shall be involved in the infrastructure components as well. So throughout our course, we need to carefully understand and implement these concepts of SAS, PaaS, and years. And what we actually do at our job desk is the next question as a data engineer. Yes, we would be involved in design and planning of data storage solutions, manage and develop data processing operations that includes calculations, computations, identifying the unwanted data, identifying the correct consistent data, etc. Optimize data solutions, making sure the performance of our data is better and better day by day. And security of activities, big data analytics, and various Azure technologies, and perform data access and data ingestion and data cleansing activities called ETL activities. Next, apart from this, we have, apart from ETL, we also have data decomposition activities. Here we go on my screen. Data staging, we have something called polybase, compressions, staging, and other activities here. Data storage and encryption at rest. Here rest means like at the storage level. Encrypting the data, hiding the data, making sure we are only displaying the required details to the users. And perform the big data analytics with various data clusters, or simply say data analytics with various big data clusters. And here comes Databricks that supports something called Spark. So we have something called Spark clusters in this case. And we also have native Hadoop clusters which are taken in a different format called Azure Data Lake Analytics. So the open source activities like Hadoop are blended into Azure with nice, meaningful, and easy to understand technologies. Yes, a great technology, Azure Cloud, and Azure Data Engineer is a primary phase of Azure environment, Azure implementations. So what we learn here when we say primary phase, yes, we need to learn unstructured data, BLOB and data lake storage, structured data. So it includes Cosmos, SQL, and Synapse, ETL and data ingestions like U-SQL, NoSQL, Data Factory, and Databricks. We need to learn data analytics components like we have Azure Data Lake Analytics. It actually involves some Hadoop clusters, and Azure Databricks and analytics from there. This involves Spark clusters, and stream analytics, it involves IoT, Internet of Things, and Event Hub activities, mainly for reporting components. There are different tools we need to install in our computers. Additional run times given by cloud free of cost, and we have some APIs and other components as well. With this information, we got some idea on what we actually do at our job desk and what we are going to learn in our course practically. I assure you 100% practice oriented classes again and again. Now, for this, what we need to do? I request you to make sure you have some basic knowledge on SQL before we get started. Yes, we need to have some knowledge on SQL, some basic knowledge on preferably Microsoft SQL Server basics, and our next classes, we shall start with our lab plan, slowly step by step. So get your computer ready, and we shall be slowly starting from the base, installing SQL Server and other components, and then we need to start our practice step by step. With this information, let me tell you once again, prior knowledge of SQL Server basics. Like for example, creating tables, relations, and queries with joins. It should be fine. Even group by has nice user interface, joins, and prefer to be in TSQL if possible. But regular SQL is also okay. Good to have some SQL Server basic knowledge. That's really good one. And you are requested to have Windows 8 or higher operating system, because we need to install some Windows oriented tools like Visual Studio for Cosmos and other activities, and they require Windows 8 or higher operating system. Windows 7 is also okay, but good to have Windows 8 or higher if you can. And you also need to have a credit card to activate your Azure free trial. Okay, with this information, we'll stop for now. Make sure we have time to practice throughout the course, because sessions will be completely into technical part, and you may opt for either plan A. If you're already aware of some SQL basics, you can opt for plan A, Azure Data Engineer. If you are new to databases, or you want to have some refresher kind of thing, refresher kind of SQL, then you can go for plan B. You need to invest additional 2 more weeks for in such a case. Or plan C, it includes SQL plus Data Engineer plus Power BI, 12 weeks course. And we will be having a nice real-time project for your resume. I would be involved in your resume. I'll be taking care of your resume and FAQs and how to answer the possible interview questions on the project that we are going to mention in our resume. Complete guidance to be provided, undoubtedly. And with this information, I'll stop for now, and good to make sure we learn the things carefully on time, and you will be surely thanking us from your job desk. We'll go that way. Yep. See you soon in our actual classes. Thank you very much for your valuable time. Thank you once again. Have a nice time ahead. Thank you.